Hello, I'm Alex Gonzalez, and this is what I found in lab number 1. So first off, the purpose of this lab was just to give a visual representation of charge in the real world and let us calculate it. So some physics principles that we used in this lab were Newton's second law. We saw how charged objects interact with each other in the real world, and then we used the electric field equation. So in the lab, my tape was 25 grams, and I found that the distance between the tapes before they interacted with each other, that was 1.4 centimeters or 0.014 meters. That means the force of gravity on that 25 or 0.25 gram tape was 2.45 times 10 to the negative 3 newtons. And using that, setting that equal to our charge equation and then solving for Q, I found that the charge Q was 7.3 times 10 to the negative 9 coulombs. And then dividing that by the charge of one electron, which is 1.6 times 10 to the negative 19, I found that the number of electrons was 4.57 times 10. And I found the atoms on the sticky side of the tape to be 5 times 10 to the 17 by finding the area of the tape, which was 0.005 meters squared, and then dividing that by the area of one atom. And then I found by dividing both sides by the amount of electrons I had that the ratio of electrons to atoms was 1 electron to 1 times 10 to the 7th atoms. So in my code, I broke it down into 3 parts. So the first part, I was just creating the point charges, which I made them both spheres. And I had one just at the origin, and then one of them was that 0.014 meters above, like in the lab. And then I calculated the forces, making each one its own variable and just putting the equation into GlowScript. And then eventually I created the arrows just using those forces I had just found and having them in opposite direction to show that each one cancels out the other. And in this, I found that the two forces were equal to each other, and the code showed that the charge was the same as the one I calculated earlier. So to wrap it up, these are the questions that were posed in the lab, and I found that the magnitude of the charge on one piece of tape was 7.30821 times 10 to the negative 9 coulombs, which was the same that I had found by myself. So some assumptions that I made to be able to do this were actually all 3 of these. Just to explain, I did have to ignore air resistance because in my room there is a lot of air coming out of my vents that could have interacted with the tape, making it another force on it, or just interacting or interrupting how the bottom tape interacted with the top one. And we treated the tape as just one point charge instead of a spread out piece of tape like it is, which has different charges at each position that do make a different electric field. And then I did assume that the whole thing had the same amount of charge like before, saying that it is spread out over the whole piece of tape, which could have changed the results if I had calculated for every position. So, and if the electron did have a positive charge and the protons had a negative charge, then it would have been the same because both would have been flipped, and a neutral object like the book that I used would have had the same interaction with the piece of tape. And it's important to handle a charged tape as little as possible, because the more you touch it, it has a higher chance of returning to a neutral object and diffusing that positive charge that it had gotten in the lab.